Okay. Hi, good evening. So today we are going to continue our chemistry class and we are going to study redox equilibrium, which is chemistry Form 5 Chapter 1. Okay. So firstly, uh, what is actually redox reaction? Do you, any of you guys know or any of you guys have heard of redox reaction before?
I think I have, teacher.
Okay. Okay. So do you know what is redox reaction?
I think it's something related to reduction and oxidation, something.
Okay, correct. So, redox reaction is actually a reaction where reduction and oxidation occur simultaneously. Okay, so correct, honeys. So, actually, the word redox itself comes from the word reduction and also oxidation. So, it is a combination. Okay, so how do we actually identify a redox reaction? So there's actually 4 ways for us to actually identify a redox reaction. Um, so in oxidation, there's actually a gain of oxygen, loss of hydrogen, loss of electron, and also gain of oxidation number. Whereas in reduction, since reduction is actually the opposite of oxidation, so in reduction, there's going to be loss of oxygen, gain of hydrogen, gain of electron, and also loss of oxidation number. Okay, so for today's class, we are going to go through these 4 things one by one, and please inform me if you have any question throughout the class. Okay. All right. So the first one that we are going to go through is actually redox reaction in terms of gain and also loss of oxygen. So this is actually an equation, okay, a reaction between magnesium solid and also carbon dioxide gas. So this reaction will actually form magnesium oxide and also carbon solid. Okay, so just like I said just now, oxidation is actually gain of oxygen. So can anyone tell me which one of the reactant, okay, of the 2 reactant that actually undergoes oxidation? Can Fakira answer?
Magnesium.
Okay, yes, correct. So magnesium, as you can see, magnesium actually changed from magnesium to magnesium oxide. So magnesium gain oxygen, therefore magnesium undergo oxidation. So if magnesium undergo oxidation, automatically carbon dioxide will actually undergo reduction. And as we can see, there's actually a loss of oxygen here. Okay, anyone else have any question?
Teacher, can I ask a question?
Yes, Haida?
How about the oxygen in carbon, the O2, CO2?
Mm-hmm.
The O2 is undergo oxidation or reduction.
Oh, is it a thing? I'm sorry. I'm
Okay, I understand.
okay. You understand?
Yes.
Okay.
Thank you, teacher.
All right. So sorry, this slide it moves on its own. So anyhow, in conclusion for this one, magnesium actually undergo oxidation and carbon dioxide actually undergo reduction. Okay. So the oxygen here, this one is actually a combination of carbon and oxygen. So it is actually a carbon dioxide. Okay. Sorry, I kind of, I didn't understand your question just now. Okay. So it's like one molecule like that. Okay. So next one is actually redox reaction in terms of gain and also loss of hydrogen. So we have here a hydrogen sulfide that reacts with chlorine gas and it forms sulfur solid and also hydrogen chloride. So this is a hydrogen chloride because it's in gas form. It's not hydrochloric acid. Okay, so just now I mentioned in oxidation, there's gonna be a loss of hydrogen. So Farhana, can you tell me out of hydrogen sulfide and chlorine, which one actually undergo oxidation?
Hydrogen sulfide.
Okay, good, correct. So hydrogen sulfide actually undergo oxidation because there's actually loss of hydrogen, whereas chlorine undergo reduction because there's actually gain of hydrogen. Okay, so the third one is actually redox reaction in terms of electron transfer. So for this one, it's a little bit tricky because you have to know what kind of ion, either it is a cation or anion that is formed by the 2 reactants. So for example, in this equation, we have magnesium undergo combustion with oxygen forming magnesium oxide. Okay, so magnesium actually transfer an electron to the oxygen. So as we know, because you have learned in your form 4, magnesium actually forms magnesium 2 plus, a cation, whereas an oxygen actually accepts electron forming oxygen ion, which is an anion. Okay, so because magnesium actually transfer the electron to the oxygen, making it undergo oxidation, and oxygen accepting electrons, making it undergo reduction. Okay, any question for this one?
Teacher, so basically to understand oxidation, it gives electron,
Yes,
and then
correct.
reduction, it gets the electron, is it?
Yes, correct.
Alright.
Okay, because redox occurs simultaneously. If one reactant gives something, the other reactant has to accept something. Okay, so you cannot just fly around like that. Okay, okay, and then lastly is redox reaction in terms of change in oxidation number. Okay, so basically oxidation number is actually the number or the charges of the electron. Electron. The chemical lah, the compound. Okay, so for this one we have carbon and also oxygen. Where's my pointer? Okay, so carbon and also oxygen react forming carbon dioxide. So firstly, you have to know what is the oxidation number of carbon, oxygen, and also the individual carbon and oxygen in CO2. Okay, so carbon actually has 0 oxidation number, oxygen has 0 oxidation number, whereas carbon in CO2 has positive 4 oxidation number, and oxygen has negative 2 oxidation number. So this one, why carbon and O2 has 0 oxidation number, how you can actually memorize is that if actually it is a molecule made up of the same atom, okay, like carbon or oxygen and oxygen, it actually has 0 oxidation number. Whereas if it is actually a compound made up of, you know, 1 or 2, or sorry, 2 or more, okay, it has its own oxidation number. So the oxidation number is actually equal to its charges, okay. So for carbon, it's very rare for us to use. That's why some student doesn't really know. But for oxygen, oxygen is negative 2. If you find chlorine in HCl, it should be negative 1, okay? Or copper sulfate, so Cu should be 2 plus, okay? So as you can see, this carbon, okay, in the reactant, okay, it has 0 oxidation number, whereas when it becomes a product, it has +4. So, Hanis, can you tell me, is this an increase or a decrease in oxidation number?
Increase in oxidation number.
Correct. So increase in oxidation number, therefore this one undergo oxidation. So oxygen, it decreases in oxidation number, therefore it is actually undergo reduction. Okay. We have gone through all 4. So anyone has any question before I summarize today's class?
Sure.
Yes.
If H2Cl2 means the oxidation number is 0.
Yes, correct. H2Cl2, what else? N2.
Okay.
Yeah. All right. Okay. So, in conclusion, okay, this is the one formula that I came up with. Okay, so I hope you guys can remember. This actually helps you to memorize what takes place in oxidation and what takes place in reduction. So in oxidation, okay, it actually has a gain in oxygen and also increase in oxidation number. How you can actually memorize is just remember O. In O, there's increase in O, O2 and also ON. And therefore, the other 2 is just a loss or decrease, which is electron and also hydrogen. And since since oxidation is the opposite of reduction, so reduction is the opposite of this. So when you are trying to memorizing 2 different things, just memorize one, and then the other one is the opposite of that one. Okay, so I think that's all for today's class. So this actually sums up this part of redox equilibrium. Does anyone have any other question before I end today's class? No. Okay, so thank you for being very cooperative for today's class. That's all for today. Thank you.